Yeah, I'm trying to kind of yell at you guys. Ah, oh, you can't hear it out there. Oh, okay. That's too bad. All right. We want to praise all the people who are back here already. They're helping us keep things on time today. Okay, I think we'll get started now. So we've already recognized that there are people from all over Germany here today. We have people from Hamburg and Frankfurt and of course Munich. But today we have someone representing Passau on our on our roster. Let's hear it for Passau. Sorry? Waldorf as well. Yes, of course, yeah. Don't want to forget
small
Waldorf.
Towns.
Yeah. So I'd like to introduce Christian Lechner, who's going to tell us about a topic on everyone's mind today, text analysis with HANA. So thank you.
Okay, then I will start. I don't need a whiteboard, but the tags are wrong. So it's about text analysis, not about security and XSS. Just to stick to my former speaker. Okay, I will tell you now a little bit about text analysis. First, I want very shortly to motivate why I think this topic is important. Then I will show you on the slides and also on the system what you can do with SAP HANA concerning text analysis. And then what you can do in order to enhance the options that you have within SAP HANA in order to build custom dictionaries, custom rules to make your own text analysis. Okay, so very shortly, motivation, why do we need text analysis? Well, there are several studies out there that say that most of the data that we have within companies are unstructured, but they contain very useful business information. This data might origin from different sources, like letters from the customer, social networks, and so on and so forth. And there is one problem with this data. It's unstructured. And the problem with unstructured data is it's not organized. You have no real predefined data model, and you cannot really query it. You have no metadata. You have a mix of data and metadata. So, which means at the end that we have a lot of information within our databases, but we cannot use it. And the solution for that is text analysis. So text analysis usually has to do the job to extract high quality information from texts. And here are listed the basic steps of a text analysis, no matter on which technology you make it. You parse the text, you add features, like linguistic information. Is it a verb? Is it a noun? Is it a punctuation? Then you have some more sophisticated ways to deal with the stuff, like entity recognition. Is this entity an organization? Is it a person? And you have also a quite powerful part of text analysis, it's sentiment analysis. So what sentiments are hidden within the text? And last but not least, the last step of text analysis is you insert the information into the database in a structured manner, so then you can work with it. So you first analyze, you save it, and then you can work with it. Okay, so what's in HANA? So most of you, I think, know this overview picture of SAP HANA platform with the database services, extension application services, and so on and so forth. And there is one cool processing engine in there that's, from my point of view, often overlooked. That's the text analysis engine that comes with SAP HANA out of the box and can be used. And building such a text analysis index is really simple. So the starting point is a database table where there is some text in there. This can be the plain text, varchars, blobs, no matter. And then you simply create a full text index on the table. Let this full text index do the job of text analysis, and the syntax is given here. So on the first line, we create the full text index, give it a name, like my full text index. Say on which table this full text index shall be created and which column shall be used. And then the magic happens within the second line. This is where you hand over the configuration. The configuration tells the index creation which aspects shall be used in order to build up the text analysis, the text index. Then you switch the text analysis on. I think that makes sense. And then you have some other options in order to, well, tune the text analysis, like saying if there is a language column within your database table, you can specify that, and then the text analysis can use this language column in order to route to the right dictionaries. You can also do auto language detection. That's not supported for all languages, but just for some. And if it's a MIME file, you can also specify the MIME type in a separate column. This will then be used in order to do the text analysis. There are a lot of other options. Most of them are not relevant for text analysis, so I will not go into detail of them. And the interesting thing is then the entity extraction that comes with SAP HANA. So in order to get this valuable information out of the texts, SAP delivers 4 configurations for the entity extractions. And these configurations really focus on business aspects. So we have an extraction core, which does a basic extraction of entities, like is it a person, is it an organization? Then we have extraction core enterprise, extraction core public sector, which focus either on something like stock market information, or public sector is everything that could happen between people. One example would be if someone's a journey, this configuration can extract from the text what was the starting point, what was the end point of the journey, and so on. And the last one, the voice of customer configuration, is the one that does the sentiment analysis. So this extracts the sentiment information out of the text. It can also extract profanities out of the text. So let's make a short demo in order to show you that. And as announced, there will be some Bavarian profanities in there in order to give some local coloring of this event. I hope everybody can see it. I cannot make it much larger because the screen is a little bit condensed on my side. So we have some sentences here. We have a database table where it says Christian loves HANA, Christian loves BF plus even more, which is true. Christian thinks that fetching HCP prices sucks, which is also true. And then 2 German or Bavarian sentences. Der Sepp ist so ein Haumdauer. Und Max ist so ein Zipfiglatscher. For those of you who are not familiar with the Bavarian language, it's profanities. Sepp and Max are both people you don't want to have within your project team. Okay, when you run text analysis on such a table, what the system does is it creates an additional table, which is shown here, with $TA for text analysis _ and then the name the index that you gave when you executed the statement. And these tables always have the same structure. What we see here, we have some IDs concerning the, which is a link to the database table to some extent, so which sentence was extracted. Then you have the rule. We used voice of customer entity extraction, so it's an entity extraction text analysis rule. And then you have additional information that mostly depends on the rule that you used. So if we take a look here, it really extracts several tokens, like Christian loves SAP HANA, and it then specifies the type of this information. And as we did sentiment analysis, it says it's a sentiment, and loves is a strong positive sentiment. For English, this works quite well. For Bavarian language, SAP has a little gap. So we just have extracted 2 persons, and that's Sepp and Max. And this is definitely a problem. And this is something that you have to solve. So there is where the enhancement options within the text analysis come into play. One basic enhancement option is to enhance the dictionaries that are used in order to build the full text index. So dictionaries are the basis in order to build the full text index. They just contain, they are really like a dictionary, and they have this structure that's shown here. So you have some real world entity in the middle. And you specify this entity, giving it an entity type, like here, organization at commercial. This at commercial already shows a little hierarchy within the dictionary, so you can do one-level hierarchies. And then you have some standard form name, which is here in the example, Parcel Service of America. And then you can define variants, because nobody would write UPS with this full term, so you specify the most important variants that you want to detect. And you can also enrich this with the information, for example, that it's an abbreviation. All this information will then be extracted and put into your full text index. The workflow for this enhancement is not really complicated. First of all, you have to find a configuration that you want to reuse, because you do not want to build up the text analysis configuration from scratch. So you search one of SAP, copy it, and then you create a new custom dictionary. You reference the dictionary within your configuration, you rebuild the index, and you're done. So let's do that. Let's start to scroll. So the standard dictionaries are located within the SAP HANA repository under SAP HANA TA for text analysis. And here we have the configurations. And as I mentioned before, there are these 4 extraction core configurations which do the entity extraction, extraction core basic, enterprise, public sector, and voice of customer. What I did not mention, we have also some configurations for the lingual analysis, which can also be used. And here we also have the vocabularies. So here we have really the dictionaries that are used in order to make the text analysis. So what I already did, in order to save time, I copied the extraction core configuration, which is a very basic configuration, into my working folder here, SITMUC 2015. And we will work on that later. And then I created a dictionary file, which is an XML. And as usual in HANA, the magic comes from the postfix. All dictionaries have to have the postfix HTTP text dict. And yeah, it's a very basic XML file where you specify the entity category, meaning we have Bavarian profanities, then you make the standard form like Hamdaha, and you have different writings for sure. And also for the second one, you specify the standard form and the variant names, and you're done. So that's for the dictionary. Now, in order to make the full text index aware that it has to use this dictionary, we have to reference it. So I copied here one configuration, as I mentioned before, and I hope it's this one. It's extraction core Bavarian. And as you can see here from the comments, it makes sense to copy it, because there's often such a comment like do not modify, do not remove, do not put it in any other place. So it would not be a good idea to move it. But you have down, very far down, at the end, you have one section where you can put in your configuration also XML style. So here, we now enhance the configuration, meaning we enhance the extraction analyzer in order to take care about our dictionaries. And we give there one property, which is dictionary, and then we specify the path to the dictionary. And we have to specify the full path to the dictionary. So it's, although it's in the same package, we have to specify the full path, and that's it. So that's it for the configuration. And we can now use that configuration in order to build our full text index. This is now the statement that I shown you before. I first drop my full text index, I create my new full text index, and here I use now my very private configuration concerning Bavarian profanities. I specify the language column and I say do it. And I execute it. And I keep my fingers crossed. So the lines will now change because I changed the basic configuration. I do not use extraction core voice of customer, but extraction core. And if I do now here some, oh, come on, filtering on DE, we'll now see we do not have only the persons, but we also have the Bavarian profanities, Hamda and Zipfiglatscher. And we have the normalized form because within the dictionary we said we have one normalized form of that, and this is then filled within this special column. Okay, that's already, from my point of view, quite good. But the journey is not over yet. So the point is, with dictionaries, you can already make some enhancement, you can already make some fine-tuning. But when we assume that we have really a text that is industry-specific, that has some slang-like terms in there, we might run into a problem. Because we do not know if this text is in the right context, so to say, or if this is words that we use in order to make the extraction is really in this context that we want it to be. So the dictionaries are not powerful enough to make a full-blown text analysis. And in order to show you that, a very good example for that are sports, because they have their own slang, they have their own context. And as we are here in Bavaria, Munich, I chose one specific sport, it's CrossFit. The reason for that is that there are some funny facts to extract, and I don't like football. And the question is now, the central question is, how can we extract complex entities from the text? So for example, did somebody attend a CrossFit training? Or what is also interesting, does somebody want to join a CrossFit box? This is something like the CrossFit studio. And we can do that within SAP HANA by using text analysis extraction rules. These rules are also called Seagull rules. They are a pattern-based language in order to make real regular expression-like statements, in order to extract more complex information and in order to take into account the overall context that is used within a sentence. So it's not restricted just to single entities. You can, with these text rules, really take into account everything within a paragraph, a sentence, a single clause. And the goal of this rule is, to extract the complex facts and the relations between entities, and even identify entities in a domain-specific language. That was for you, yeah, right. Okay, the workflow is a little bit enhanced compared to the dictionaries. First of all, we have to create dictionaries, because that's always the basis. We need the basic entities to extract them. Then, next, we have to define tokens. This is something like the atomic unit in order to build up the rules. And with these tokens, we can then create regular expressions. And with these regular expressions, we form our overall extraction rules. The fourth ingredient is luck. Why? Because as you have seen it before, there is no syntax highlighting, there is no highlighting at all, there is no code completion, there is nothing. So usually when you do that the first time and play around with it, you build your dictionary that works, then you build your first simple regular expression, you create your full text index, and the full text index is empty. No error, nothing. Not even in the console. Everything runs through smoothly, so it's really great fun doing it the first time. Okay, so let's go back to the system, and I've also prepared something for that domain. So I have a second database table. I have it here. And now I think you will also see why I mean the context is important. So it's not important for the first one. Hans wants to join a CrossFit box. That's easy. Mike has his what today, what is workout of the day. And one exercise was skin the cat, which was a torture. Skin the cat and torture might have a different meaning in a different context. Next one, a classical workout of the day is death by pull-up. Death by is also something that might have a different meaning used outside of CrossFit. And the last one is also easy from a point of view that we as humans understand it. Michael does not want to join a CrossFit box, but it will be more complicated to extract between the to distinguish if he wants to join or not, because you have various variants to say I do not want to. So when we do a regular full text index on that table, and I did that, we will see that there is not too much information that comes out. So we basically have 3 persons. That's it. That's all that extraction core or sentiment analysis can bring out of the text. So we really have to enhance everything. And once again, we can do so. I will close those ones. Okay. So first step, again, we copy one configuration file, the extraction core. I've copied one extraction core CrossFit. And we have to create a dictionary. As before, it's in the same format, because there is only one format in order to define a proper dictionary. And I have now once again defined my entity category. I have defined my entity name in the standard form, and I have defined several variants in order to take care of the variants. And you also have the option to auto-generate additional variants. This is just for the sake of explaining it here. If you think about companies and you have these nice little postfixes in companies, limited, LTD, whatsoever, you do not want to put all or to type in all these variants. You can define templates for that in order to trigger the variant generation. And this is something that can be done either automatically for companies. SAP delivers such a template, but you can also make custom variants. And then we have workout. Then we have, for those of you who wondered what is Skin the Cat, it's an exercise for your abs, for your abdominals. So we have one category for Skin the Cat and for other stuff. We have another category for the pull-up. And so on and so forth. So what we have now, we have the option to extract the basic entities. But once again, Skin the Cat might be difficult to get the right context. And that is where the rules come into play. And we have here one rule, which is the artifact HDB text rule. And we have here one bug within the web IDE, which is the little thing here. It's the rule RT. It's just displayed. It's the runtime representation of my rule. And it's displayed in web IDE. But it's not editable. It's not displayed in Eclipse, but it's a bug within, I think, revision 90 and so on. So this is now the way you would define a rule. And there are several ingredients that you can use within that rule. So let's start from inside out. What we have here is we define here one token. Perhaps I mark it here. That I've defined which expression markers. TE is an entity. So every time there is an entity that is of the type person, it will be referenced to a subgroup, so to, let's say, a submodule that I call trainee. And we have also the option to overwrite the way this entity is extracted. So as we saw before, usually this entity is extracted and it would have the tag person. We can overwrite that by using this OD, which is called object delimiter. And we overwrite within the rule the semantical meaning that we want to see in the full text index. We can do the same for CrossFit or for exercise. And then we have one subgroup which is a little bit more complex. Here we already specified not only one entity that we extract. Here the entity that we have referenced within our dictionary. So here the dictionaries come into play. The full text engine uses the dictionaries in order to extract the entities, and within the rules I can then use these extracted entities from the standard configuration, but also from my configuration, because bar exercise, app exercise, workout were not defined within standard dictionaries. And I can also add here some additional information within these brackets here. We can define so-called tokens. These are these atomic units. You can put in there either directly the word that you want to reference. You can put in the stem of the word, like be. Then you reference every variant of the verb be. And you also can specify if you have a word that can be used as verb or as adverb. You can also specify, shall it be referenced if it's a verb, if it's an adverb, or if it's not on my clock. Or not. Okay. What you also see, you have here some grouping operator. So we distinguish def if it's capital letter, lower letter. Here, this dash is the OR operator, as you would have thought. And then we can now reuse these subgroups, these modules, within our real entities that we want to extract. And these are the so-called groups. They are marked with this hashtag group. And here I have what description. And this is now really the rule. So here I want to extract as what description every clause. This is the CC at the end and at the beginning, where there is a trainee, a reference from above the subgroup, followed by a wildcard, then the token have, be, attend, do, followed by a wildcard, so there can be one or many words in between, then I reference the entity CrossFit, and so on and so forth. And these delimiters here at the front, at the end, are once again used, these expression markers are used in order to narrow the search range. Because if you think about a complete text that is within the database table, you do not want to match entities all over the text. You want to match them within one sentence, within one clause, and that's possible. The same is done here. Here we have one example for the usage of a token with the definition of stem. And here down below we have now the example concerning the CrossFit query. Who wants to join a CrossFit box? And here something like want likes to join a CrossFit box. And then I have one functionality within these rules in order to drop everything that has another word in. And in this way, I first extract all the queries, even the negative ones, and then I drop the negative ones. And in the result, I only have the positive ones. Okay, I think now I really have to speed up a bit. And last but not least, we have the configuration. Now the configuration is a little bit, contains a little bit more. We reference the dictionary in order to get our custom entities. We reference the rule. It's the same configuration part within the XML file. We just say we have a property name extraction rule and we reference it. And what I've also done is you have an additional configuration option, which is the preprocessor. This has nothing to do with the preprocessing engine within SAP HANA. All the text analysis is done within the preprocessing engine. This is something like you can filter the values that you want to extract. So I don't want to have the trainee, the person, and all that stuff. I just want to have these three entities in order to extract them. And now let's see if that works. So I start creation of the full text index. I redo it, and we have all the three tokens correctly extracted. So Hans wants to join a CrossFit box as a CrossFit query. The other person who did not want to join is not extracted. Mike has his what today, was skin the cat, was a what description. Classical what is death by pull-up is a what type. So everything worked out fine. And our rules, our dictionaries were used in order to get the result. Okay. So text analysis with SAP HANA, summary or lessons learned. From my point of view, text analysis in SAP HANA is extremely powerful. Besides the delivered content, you have a lot of options to adopt it. So you have quite some powerful configurations already in place, but you have really a lot of degrees of freedom in order to adopt it. This also means that you have a lot of options that can go the wrong way. And I think I've seen a lot of them. And what's important is when you start with text analysis, and especially when you start with text rules, do it from SP9 upwards. Why? Because in SP8 you had to compile the rules outside of SAP HANA and then deploy them to the file system, which is not cool. Now you have it the real way as you would expect it for artifacts within the HANA repository. They get activated and compiled during activation. Documentation, I have to say, is really mostly okay, but it has room for improvement, especially in case from extraction rules. So you can find some way into the rules, but there are also some, from my point of view, examples that do not bring you forward, like explaining rules with using French grammar. I don't know if that's the best way. And as I said already, creating custom dictionaries and text rules can be really quite cumbersome in order to find an error, because everything runs through smoothly. Just the full text index stays empty. There's no way to debug it. There's not, at least not when you're at customer side. Okay, that was it.
Thank you. Thank you. Does anyone have questions?
Thanks for a very good presentation. Makes me try out this on my own. Question: when you extract such a statement like XY wants to join, for example, something, are you also able then in some kind of logic to extract, for example, this Michael token, for example, for further processing?
Yeah.
Okay.
For sure. Or do you mean if Michael as a name itself? Or?
Yeah, because I think the first part would be to identify the total statement somebody wants to join, and in the second step you want to...
you anyway have that because within the full text index table you have the token, which is Michael, and you have identified it as a person, and we are the ID column. You can reference it, but this is the sentence where it happened. You also have additional information in there that I did not show you. You can identify the paragraph where it is. You can identify exactly the beginning of the word within the paragraph, where it started, and so on. So you have a lot of degrees there.
Yeah. Just one remark. You said that it's really the automatic compilation works only starting from SP9.
Yeah.
Unfortunately, this is for HANA trial. HANA databases, I think, are still at SP8. So it would be really nice if those. That's really great.
So good news.
So HANA trial is now on SP9.
Okay. Do you have to?
I will check.
Create a new account, or because yesterday I checked it was.
Yeah, 85. Yesterday it was 8.
Please cross-check.
Yeah, that's also the reason why I mentioned it, because on the HANA trial you cannot try it.
Okay, Christian, I have the question. You showed very nicely this domain-specific dictionary, and so my question is, what is your interest from your industry's point of view? I mean, what kind of text searches you want to do, and what is your opinion? Is this, I mean, this tool is needed, isn't it? I mean, I don't want to do search for cinema titles or what the examples are, but as an insurance or a bank, I want to analyze protocols of customers and find out something, isn't it? What is your experience?
So we are currently gathering some experience with within the human recruiting part by parsing CVs and extracting skills. But this is currently running, and we are, getting our first impressions, how good it works, how bad it works.
So finding all these domain-specific vocabularies and defining the categories then is done manually, isn't it?
Currently,
you must sit down and read the
Yeah.
CVs and do the analysis and.
Yeah, you have the initial setup has to be done by hand. Yeah, exactly.
Okay, so for you it would be good to have a kind of trace somehow to find out like subjects of sentences or grammar structures.
Yeah.
To see amounts of tokens appearing in a text, something like this.
Yeah, that's already possible with doing the linguistic analysis that I didn't show you.
That's part of HANA too?
Yeah. So these are the other configurations that I did not show you because they are a little bit boring from presentation point of view. Because you tokenize a sentence and you say this is noun, verb, punctuation, and then you can count it and so on.
I have a question regarding that training ability of the text analysis. Is there any self-learning feature planned or a UI which you can give to end users that they can train the text engine somehow?
You're asking the wrong person, so I don't know. I would hope so, but currently it's as you have seen. That's the way it's.
So only expert tool, nothing you can give to the end users.
There's no nice and neaty UI5 app where you can enter something like your dictionary in a quite well, not so error-prone way as it's here. Yeah.
Thanks.
Probably another question regarding custom dictionaries. Am I right that enhancing a custom dictionary requires total rebuild of the whole full text index? So each time you add another token in your custom dictionary, you have to recreate this.
You have to recreate the index.
So there is no delta yet.
Nope. That's right. That's correct. So for the so to say for the base load that you already have your full text index on, you have to recreate that. Yeah.
Hi. So my question is regarding the sentiment analysis. We could not see the demo, but the question is like, what is the possibility to capture the emotions in the text? For example, there are some smileys, some sad.
So that's also extracted from SAP standard.
Yeah.
Yeah, that's possible.
But sometimes we see that we have a dictionary where we capture the sentiments like person is sad, but maybe the smiley is happy. So how do you tackle in those cases?
I did not try that out on SAP HANA up to now, but I think then it struggles. So I have seen one sentence, and that was then analyzed on SP8, and there was the sentiment analysis was a bit shaky, and there you can quite easily trick the sentiment analysis exactly by the way you mentioned.
Yeah.
Simply saying the negative sentiment and then putting some positive stuff behind it.
But I think the side remark, even outside of HANA, there are I have not heard of any text analysis solutions which are able to clearly work with this kind of different messages, like different. So, for example, different notions about the same thing. I think there is every solution today with this.
I have read only in some papers, but I have not seen the solution yet. So
yeah, so.
Okay, well, thank you for all the great questions. We have to take a short break. Thank you to Christian while we're. And while we're filtering out all the tweets from SIP and Max, we'll let